Greetings to all viewers. This is Professor Ankit Singh. We'll now move to the next topic, that is vertical alignment. The vertical alignment of a road consists of gradients and vertical curves. Okay, so there are two elements that we need to consider under vertical alignment. Those are gradients and vertical curves. The vertical alignment is usually drawn as a profile, which is a graph with elevation as vertical axis and the horizontal distance along the center line of the road as the horizontal axis. Okay, so the vertical alignment, we draw it as a profile, okay, using two axes, the x and the y axis, where we use elevation on the y-axis and horizontal distance along the center line of the road on the x-axis. Just as a circular curve is used to connect horizontal straight stretches of road, vertical curves connect two gradients. Okay, so we already know about horizontal curves. These horizontal curves are used to change direction of a road, okay, or join any two roads. Here what vertical curves do are vertical curves join any two gradients. Okay, in order to smoothen the gradients, the contact points of the gradients, what we do is we provide curves. Those curves are known as vertical curves. When these two curves meet, they form either convex or concave shape. Okay, so at the point of intersection of the two gradients, okay, this is gradients. When two gradients meet, the shape of the curve is either convex or concave. I'll show you that. Okay, now this is one gradient and this is the other gradient, and at the intersection a curve is formed here, and this is a convex shaped curve. Okay, the convex shaped curves are known as summit curves, while the concave shaped curves, like this one, this is one gradient and this is the other one, we are joining them using a vertical curve. Now this here is a concave shape, and these type of curves are known as valley curves. Okay, we'll learn about this in detail. The former is called the summit curve. Okay, the ones with the convex shape are known as summit curves, and the ones with the concave shape are known as the valley curves. Now, gradient. Let us try to understand what we mean by a gradient. Gradient is the rate of rise or fall along the length of the road with respect to the horizontal. Okay, so in the direction of movement, in the longitudinal direction, it is the rise or fall of the road. Okay, the rise of the road or the upward slope is positive, is taken as positive, and the downward slope is taken as negative. It is expressed as a ratio of 1 in x, where 1 is vertical and x is horizontal. Okay, 1 vertical unit to x horizontal units. Now these units could be meters, could be kilometers, could be centimeters, or anything. Okay, sometimes the gradient is also expressed as a percentage. Okay, so we can either express it as 1 in x, where 1 is vertical and x is the horizontal, or in percentage. In percentage, for example, if you say 5%, then 5% can be written as 5 divided by 100. So this means 5 vertical units to 100 horizontal units. While aligning a highway, the gradient is decided for designing the vertical curve. Okay, before finalizing the gradients, the construction cost, vehicular operation cost, and practical problems in the site also has to be considered. Okay, so while we try to design the gradients that we need to provide for the road, we need to consider these factors, which are the construction cost, vehicle operation cost, and other practical problems at the site. Usually, steep gradients are avoided as far as possible because of the difficulty to climb and increase in the construction cost. Okay, so what we do is we try to provide gentler slopes. Okay, the slope should be gentle, or the gradient should be gentle with less gradient values. Okay, we try to avoid steep gradients. Okay, because as the gradients tend to be steep, the vehicular cost increase, vehicle operation cost increase, and also the construction cost increases. Okay, now the next topic is types of gradients. Okay, there are four types of gradients that we use on the roads. Okay, for design purpose, let us look at them. Many studies have shown that gradient up to 7% can have considerable effect on the speeds of the passenger cars. On the contrary, the speeds of the heavy vehicles are considerably reduced when long gradients as 2% is adopted. Okay, so the speeds of heavy vehicles are reduced when we provide longer gradients. Okay, the longer gradients would mean a gentler slope. Okay, a gentle slope of 2%. Okay, so at this value, the speeds of heavy vehicles are considerably reduced. Although flatter gradients are desirable, it is evident that the cost of construction will also be very high. Now what happens is, if we try to provide flatter gradients, then obviously the length of the road would increase. Okay, since the slope is less, the length of the road would be more. And in the other case, if the slope that we provide is high, then in that case, to reach from point A to point B with a higher slope, it would require lesser distance. Okay, so lesser length of road. Lesser length of road would mean lesser construction cost. Okay, therefore IRC has specified desirable gradients for each terrain. Okay, so what IRC has done is, for each type of terrain we have given a set of gradients. Okay, out of these gradients we select whichever is suitable for that type of terrain. However, it might not be economically viable to adopt such gradients in certain locations. Steeper gradients are permitted for short duration. Okay, so what we do is we do not provide these steeper gradients for a longer span, okay, or longer length, because these type of gradients require higher haulage capacity, okay, higher load carrying capacity, and vehicle operation cost is more. Okay, so what we do is we do not provide them for longer durations but for shorter durations. Okay, now the classifications are of four types. First type is ruling gradient, second is limiting gradient, third being exceptional gradient, and fourth is minimum gradient. These are some of the types of the gradients that are used. Okay, now let us try to understand what these gradients mean. First one is ruling gradient. The ruling gradient or the design gradient is the maximum gradient with which the designer attempts to design the vertical profile of a road. Okay, so ruling gradient is nothing but the design gradient of the road. It is the gradient value that is used in order for the road design. Okay, this depends on the terrain, length of grade, speed, pulling power of the vehicle, and the presence of the horizontal curve. Okay, so in the presence of horizontal curves, what will happen is we will not be able to provide steeper gradients. We will have to provide gentler gradients. In flatter terrain, it may be possible to provide at gradients, but in hilly terrain it is not economical and sometimes not possible also. Okay, what happens in flatter terrain? We can provide longer gradients, okay, with steeper values, but in hilly terrain it is not economical to provide longer gradients. The ruling gradient is adopted by the designer by considering a particular speed as the design speed and for a design vehicle with standard dimensions. Okay. So for considering the ruling gradient, we need to have a design speed. Okay. We already know what design speed is and what are the standards. There are few standards provided by IRC. Okay, which we have looked up into our previous classes. We use those values with respect to the type of terrain and then we decide the ruling gradient. But our country has a heterogeneous traffic and hence it is not possible to lay down precise standards for the country as a whole. Okay, since the traffic conditions are heterogeneous, meaning that in our traffic there are different classes and different types of vehicles available. Okay, there is not a single standard vehicle that we use. Okay, hence IRC has recommended some values for ruling gradient for different types of terrain. Okay, so there are a few recommendations provided by the IRC. We need to use them for design. Now the second type of gradient is limiting gradient. This gradient is adopted when the ruling gradient results in enormous increase in the cost of construction. Okay. Now, if we are providing a gradient from point A to point B, that is a ruling gradient, and if the length is too much, okay, and due to this huge length, the cost of construction is more. Then in that case, in order to reduce the cost of construction, what we do is we provide a limiting gradient. Limiting gradient is nothing but a steeper gradient as compared to ruling gradient. Okay, on rolling terrain and hilly terrain, it may be frequently necessary to adopt a limiting gradient. Okay, why? Because on rolling terrains and hilly terrains it is difficult to provide gentle sloped terrains. Okay, so in these cases what we try to do is at some stretches of roads, wherever possible, we provide limiting gradient. When we provide limiting gradient, the length of the road reduces and hence also the cost of construction would reduce. But the length of the limiting gradient stretches should be limited and must be sandwiched by either straight roads or easier grades. Okay, this means for whatever length we provide the limiting gradient, it should be sandwiched in between either two straight roads. Okay, straight roads would mean gentler slopes, or any two gradients which are lesser slope values than the limiting gradient values. Okay, now a similar type of gradient is the exceptional gradient. Okay, exceptional gradient are very steeper gradients given at unavoidable situations. Okay, they should be limited for short stretches and not exceeding about 100 meters at a stretch. So these can be provided only for a length of 100 meters at once. Okay, in mountainous and steep terrain, successive exceptional gradients must be separated by a minimum 100-meter length gentler grade. Okay, so these exceptional gradients are even steeper than the limiting gradients and these can be provided only for a stretch of 100 meters. At hairpin bends, the gradient is restricted to 2.5%. So if there is a hairpin bend, then the gradient or the maximum gradient that can be provided, the maximum slope that can be provided is 2.5%. Now the fourth type of gradient is minimum gradient. This is important only at locations where surface drainage is important. Okay, so the minimum gradient is nothing but the longitudinal gradient along the road surface or the longitudinal drains, the slope at the longitudinal drains or the road. Okay, this is used for drainage purpose of water. Okay, camber will take care of the lateral drainage. As you already know what is camber, it is the lateral slope provided on the road. Okay, so this take care of the lateral drainage, and the longitudinal drainage taken care by the minimum gradient. But the longitudinal drainage along the side drains requires some slope for the smooth flow of the water. Therefore, minimum gradient is provided for drainage purpose, and it depends on the rainfall, type of soil, and other site conditions. Okay, so this slope will depend on three factors: rainfall, type of soil, and other site considerations. Okay, a minimum of 1 in 500 may be sufficient for concrete drain. Okay, and 1 in 200 for open soil drains are found to give satisfactory performance. Okay, in the case of longitudinal drains, if the material used is concrete, okay, since concrete does not absorb water, okay, a gentler slope can be provided, so 1 in 500 can be provided there. But for open soil drains, okay, for drains made up of soil, a steeper slope is to be provided, that is a standard value given by ARC is 1 in 200. Okay, now the next topic is grade compensation. I'll continue with this topic in my next lecture. Thank you.